So we kind of changed our pacing a little bit this semester from what we've done in years past. And because of it, we were able to bring in factoring by grouping, which some of you have probably done before, but some of you have not done before. And so I'm going to talk you through that. But before we get to the factor by grouping stuff, we're just going to look for a GCF. Anyone remember what a GCF is? Yeah, it's the greatest common factor. So, factoring, okay? Whenever we tell you to factor completely, the very first thing you should do on every single problem, okay? This should be your go-to first step, is to look for a GCF, a greatest common factor. So, in other words, look for something that every term in your polynomial is divisible by, is one way to think about it, okay? So step one, you are going to find the GCF, greatest common factor of all the terms of the polynomial. Step two is you're essentially going to use the distributive property, but in reverse, to factor out that GCF. And really what it ends up looking like is division a lot of the time. If you think about the distributive property, if you have like 2x times x minus 4, right? To distribute that, it would be 2x squared minus 8x, right? Instead of doing this to get to here, you're going to have this and need to get to there. Okay, so it's reversing the distributive property, which if you think about it, the way I can do that is I can say, well, what's my greatest common factor in a 2x squared and an ax? Well, I can divide 2 and 8 by what number? 2. And I can divide an x squared and an x by what? An x. Okay, so you're taking out a 2x, and then what you're left with is an x minus 4. Okay, so we're just reversing the distributive property. In other words, doing some division, okay? So let's take a look. Number one here, all we're going to do is factor out a GCF. We're just going to figure out what could I divide everything by and rewrite our expression in factored form, okay? So take a look at 5x plus 15. And you have two separate terms here, right? You have a 5x and you have a 15. So look at the number part of it. A 5 and a 15, what can you divide both of those by? 5. Okay, now look at the variable part of it. An x and nothing. What can you take out of an x and nothing? Nothing, right? There is no common factor there. So all we can take out of this is a 5. Well, now it's like we're dividing by that 5. So if I divide by 5, 5 over 5 is x left there. And then 15 over 5 is a 3, and you just keep the sign, unless, of course, you're dividing by a negative, which we're not. So it's 5 parentheses x plus 3. Okay, that is factoring, the GCF. Take a look at letter B. You have a 12 and a 24. What can you factor out of 12 and 24? A 12, yeah. So we know it's going to be a 12. What can you factor out of an x squared and an x? Just x to the first. Okay. Side note, when you have the same variable, you're always able to factor out the lower exponent every single time. So if there's an x to the third and an x to the second, you can factor out an x to the second. Okay. This one, there's just an x. Okay. Then you have a y and a y. What can you factor out of y and y? A y. Okay. So now, if you're essentially dividing by 12xy, that way. 12 divided by 12 is 1, so your number is going to go away. You may put the 1 there. You don't need to. What's x squared divided by x? Just an x. Y divided by y is 1, so you don't need to put it in. Plus, and then 24 divided by 12 is 2. X divided by x, y divided by y. I made my parentheses way too wide. So you get this. Okay. Tell your neighbor what C is. What can you factor out and what are you left with? Tell them your factored form. awfully quiet for so many neighbors in the room. All right, tell me what you factored out. What do you factor out of 10p cubed and 2p? 2p, right? They're both divisible by 2p. So if I factor out a 2p, what are you left with here? Essentially, you're dividing by 2p, right? 5p squared plus 1. The p's went away. 2 divided by 2 is 1. So this is your factored form. Okay, this one looks a little intimidating because there's lots of things, but take it one piece at a time. Look at the numbers, look at the x's, look at the y's. It's not so bad, okay? Number-wise, what number can you factor out of 6, 9, and 12? A 3. Okay, then you have an x cubed, x squared, x squared. What can you factor out? X squared. Remember the lowest exponent that you have. And then y to what power? The first, right? This is y to the first, so you can just factor out a y there. And then when you do that, you're essentially dividing by 3x squared y everywhere. Right? So if you do that here, you get a 2x. Do you remember the process when dividing with exponents? What do you do with the exponents? You subtract them. 4 minus 1 is y to the third. Okay, here you'll have a 3. This is a 1, this is a 1, so that's the number 1. X squared over x squared is the number 1, so all you really have there is a 3. And then plus what? 4y to the second. Okay, I'm not going to be real concerned about order right now. Mathematically speaking, they'd probably flip-flop those last two because you usually do bigger exponents first and a constant at the end, but I don't care. You can leave it like that. All right, you try E. This one you could argue a different answer than I'm going to come up with here. Anyone know why? Negatives, yeah. I would say if there are more negatives than positives, then take out a negative, okay? We always shoot for more positives than negatives. So what did you factor out? You did 10? Okay. I would do a negative 10 b to the fifth. Okay. You could argue the other way for me, but it just ends up looking a little nicer if you take a negative out of it. Because if you divide everything by negative 10 b to the fifth, by the way, you don't ever have to write this for me. I'm just writing it so that you see the process for those that would like to write it. If you factor that out, what are you left with here? B to the second. It's just nice to not have a negative out in front of your leading term like that. So is it wrong the other way? No. This is just preferred. So this one, you're going to get 10 divided by a negative 10. So this becomes negative, but it's just a 1. And then b to what power? To the first, right? So you can just write that as b. And then this is a negative divided by a negative, so that's a positive. Again, it just gets you less negatives. And then b to the fifth over b to the fifth is 1. So this is your factored form. Okay? All right. This is probably new to most of you. If you took Algebra 1 here, this is probably new to you because we don't do this in Algebra 1 at Valley. At least we didn't. Maybe we start now.
I think they did it in 8th grade.
Did you do it in 8th grade?
They did.
That could be. So this one says factor out the binomial GCF, okay? Which means a binomial is what? Two what? Two terms, right? You have two terms in parentheses like that. That's a binomial. So there's some binomial that you can factor out of both of your current setups. They're pretty straightforward. It just feels funny because it feels like, why are we doing this? But you'll see down the road, it comes in handy when you can factor out the same thing. So you have an x plus 2 and an x plus 2. So if you think of it as like 5x squared and 9x, it's like factoring out an x, but there's just more to it. We can factor out an entire x plus 2 in this. So if we factor out x plus 2 here, then what you're left with is the rest of it, right? If I factor out an x plus 2 here, if I divide by x plus 2 here, I'm left with a 5x. And if I divide by x plus 2 here, that goes away. I'm left with a 9. So now I have a binomial times a binomial, okay? So when you factor out the x plus 2, you just get a simpler setup. You get this factored form where it's binomial times binomial, okay? So what are we going to factor out of b? What's the same in b? The x minus 4. So if I put that x minus 4 out in front, then if I divide by x minus 4, I'm going to be left with a 3x and a minus 8. And that's my factored form. Okay, so it just simplifies it, right? It takes it down to two binomials instead of these other terms that are kind of floating around there. Okay, so factor out the binomial, the x minus 4, and then write what you're left with as a new binomial. Okay, so you write out C, how you think you should write that. Side note, if you flip-flop those, if you wrote 3x minus 8 times x minus 4, it's okay, right? You can reverse the order. It's multiplication. Multiplication is commutative. All right, what'd you write for C? 4a minus 5. Good. Okay, this one's a little fancier. I need you to think about what we just did on the last three problems, and then think about what that means you should be left with, okay? This one is binomial plus binomial times binomial. So what can you factor out of it? The x plus 3. The x plus 3 is the same, so we can factor that out. Okay, what we're left with, we said we do what we see. So like on this one, we were left with a 4a, and we went 4a minus 5, right? On this one, we're left with more. We're left with two binomials. So we would take the x plus 7 and add the 3x minus 2, right? So now you're going to be adding the two binomials that you're left with. What can you do from here? You can simplify. So you have an x plus 3. That's going to stay put. But these can actually be added together. X plus 3x is 4x. 7 minus 2 is a positive 5. And now this is a simplified factored form, okay? So when it's binomials plus binomials like that, you're going to be combining with whatever this symbol is, adding or subtracting those two binomials, okay? Questions on that? Okay, last thing. I love this one, factor by grouping. Maybe you've done this before, maybe you haven't. But when you see an expression that has 4 terms, you are going to factor them by grouping them. Okay, so there's 4 different terms. Notice, at least on this one, and a lot of the time on factor by grouping problems, not always, but a lot of the time you're not going to be able to find a GCF. Is there a GCF here? No, there's no variable for sure, because this one doesn't even have a variable. And then some people are like, oh, a 5, but you can't factor a 5 out of a 2. Okay, so there's no GCF to factor out. So instead, what you're going to do is you're going to group them, and typically they're in descending exponent order. If they're not, you should put it in that, but the ones I will give you will be in descending order. So we're going to group them And just think of this as two separate binomials right now. Okay, now if I factor each one of those groups, what can I factor out of the left side? You can factor out a 5. What else? And an x squared. Okay, so if I factor out a 5x squared, if I divide everything by 5x squared, what am I left with? X plus 5. Okay, so that takes care of that side. Well, I guess it's that side for you. Okay, now look at the second group that we made. That's a 2x plus 10. You can factor out what? 2. So we're going to go plus 2. And then when we divide by 2, what are we left with? X plus 5. Look how beautiful that is. Doesn't that look like what we just did? This is why you want to be able to factor out a binomial. So if this is my setup and I want to factor out the binomial, what's the binomial that I have that I can factor out? X plus 5. Okay, so I'm going to factor out an x plus 5. And I'm going to have what left? 5x squared plus 2. And that, my friends, is your factored form. Yay. So fun.
This is so easy.
Good. All right, let's try this one together, and then I'm going to have you try the next two on your own. This one, if you group it, okay, those are your two groups. What can you factor out of x cubed plus 2x squared? An x squared. So we're going to factor out an x squared, and we will be left with x here. What here? 2x squared divided by x squared is 2. Okay, so it's x squared times x plus 2. Okay, now go here. What can you factor out? A 3x and a 6. What can you factor out? A positive 3, okay? Which means we are adding 3 and then factoring it out. So x plus 2. And again, if those don't come out the same, something's wrong. Because when you're factoring by grouping, those are going to come out the same. Now let's factor it out. You have x plus 2 that you can factor out. You are left with x squared plus 3. And you're done. Questions on that? Okay, you try those last two. What did you do first on letter C? If we group this, what did you factor out of the left side? These are both divisible by x squared. So we put an x squared out in front, and then we divide it. What are you left with? X cubed divided by x squared. You're going to subtract those exponents. That's an x. And then this, so we're subtracting, what are you left with there? 6x squared divided by x squared. Those go away. Did you get a 6 there? Okay. Now look at your second group. Okay, now we've got this guy, a 4x and a negative 24. What can you divide both by? 4. So we're going to factor out that 4. We're left with x, right? That would become x. 24 divided by 4, you're going to go minus 6. And then once you see the same thing, you can factor that thing out of it. So it's going to be x minus 6. And then what you're left with, x squared plus 4, goes here. Okay. All right, tell me what you got on the last one. What was your final answer? Yoo-hoo! What was your final answer?
X minus 4 and 3x squared minus 5.
3x squared minus 5. Is that what you got? Okay, if you got that, you can start working on the homework. If you didn't get it, hang out with me for a minute while we walk through it. Factor by grouping says take those first two terms. Ask yourself what you can divide by. Don't talk, though. Just work if you're working. So we can divide a 3 and a 12 by 3, an x cubed and an x squared by the smallest exponent, which would be x squared. Okay, so we're going to factor that 3x squared out, and we're left with 3 minus 2 is 1, so that's x to the first power. Minus, because this is minus, 12 divided by 3 is 4. X squared divided by x squared is 1. So you get 3x squared times x minus 4. You don't need the 1 there. I was just showing you what it was. Okay, now look at your second grouping. Both those are divisible by a 5. Now, if you think about it here, this was an x minus 4, and this has a minus 5 here. So if we factor out a negative 5, that's going to work out a lot nicer. You're going to be able to simplify it. So divide everything by a negative 5. Factor out negative 5. You're left with x. 20 divided by negative 5 is a negative 4. And then that gets you 3x squared minus 5 here. Your x minus 4s go right there. Okay, factor by grouping. Questions on that?
That was so easy.
Good.